So today we'll be discussing about QoS and VPN. So what is QoS? QoS stands for quality of service. Quality of service. Now, why do you require QoS? Okay. The question arises, why do you require QoS? See, let's say you work in an enterprise and the enterprise traffic is working, right? The networks are very fine working. But there are situations like we call them as a peak hours. What are peak hours?
Internet we use mostly
when the resources will be used or the traffic will be at the peak or the highest. Okay. In that scenarios, what will happen? The bandwidth. There are chances that there will be congestion in the network. There might be congestion in the network. And due to congestion, what will happen? Some packets will drop. Okay. So now, whenever we talk about an enterprise network, in that there will be different types of traffic. There will be audio traffic, audio, or you can say voice traffic. There will be video traffic. There will be data traffic, right? These kind of different types of traffic will be traveling. Now, to each and every company, not a particular type. Like for all the companies, not the same type of traffic is priority. Okay. Not a same type of traffic is a priority. So what will happen with the help of QoS? Now, if your important traffic due to congestion, if your important traffic is getting dropped, or there is a latency in your important traffic, is that a good thing for your enterprise? Let's say stock market company, if you take an example, if their stock prices are not getting refreshed in the real time, they are at loss.
Yes.
Right? So for them, that particular traffic is the most important thing. Okay. Similarly, for different enterprises, if a enterprise is dealing with the video traffic, so for them, the video traffic is important, right? So what happens, let's say, for example, just consider one small example. Let's say you are at home and at home you have a Wi-Fi router, correct? And you have internet access. Now, during the daytime, okay, during the daytime, let's say the kids in the family will go to the school, okay, and the old people, they will go to their job, and others will go to study or somewhere and only, let's say, your mom will be staying at the home. So if she is using the internet connection, what will be the speed? Will be the highest. Why? No congestion in the network. And at the evening, when everybody is back to home, now when you use the internet, will the speed be same? No, it will be divided, right? So that kind of scenario it is when your network is being used the most. In that scenarios, your important traffic should not stop. Let's say you are making your company deals with the video traffic, okay, and now some people, they are watching YouTube, some people they are playing music, okay, some people they are playing online games. So different types of traffic is there, right? But if due to that traffic your video traffic is getting disturbed, that is not a good thing. So for that purpose, we have something called as QoS. So with the help of QoS, what we are going to do, we are going to simply prioritize one type of traffic over the another type of traffic. Whatever traffic is important to the company, that traffic we will assign higher priority. And if that traffic is having the higher priority, whenever all these traffics are coming to the router, what the router will check? Will check, okay, this traffic is having the highest priority. First of all, this traffic will be passed. I don't care about the rest of the traffic. My first priority is forward this traffic. This traffic should not be stopped. This is what happens with the help of QoS. Okay, so that even during the peak hours, even during the network congestion time, your important traffic, your priority traffic will not stop. Okay, so sometimes you assign higher priority. Sometimes what you do, you can say like, first of all, assign with the higher priority. Okay, second thing, what will happen whenever this traffic comes at the router? What the router is going to do? It is going to forward, means whatever all the traffic is coming here, all the traffic, it will reassemble. It will reassemble in the order of priority. And according to higher priority, it is going to pass the higher traffic first. And second thing, what you can do, you can set up a limit. Let's say if your network is 100 Mbps. Okay, then you will say that, okay, other traffic can use maximum 40 Mbps. Other traffic can use maximum 40 Mbps, means you can set up the threshold limit. Now, whenever the other traffic tries to use more than this, then certain actions will be taken based on your QoS. This is clear? Now let's see. Quality of service. Quality of service is a set of technologies, tools, and approaches that you can apply to a network. The goal of QoS is to guarantee the network's ability to reliably run applications and traffic despite limited capacity. Because see, your bandwidth will be limited. And if it is being used at the most, then it will get divided. Right? So your important traffic, maybe it will not get, because by default, what your routers and everything is going to do, whatever packet is coming first, that packet it is going to forward. This is the default behavior. So to change this behavior, we have the QoS, so that whatever high priority traffic we assign, that traffic should be forwarded first. Okay. So some QoS tools and technologies do their job by handling different packets differently. Okay, different types of packet they will handle differently. And you will throttle bandwidth in the certain circumstances, and you will change priorities on the fly. You will change the priorities of your traffic. Okay. Now for this purpose, we come across these 6 terms, or you can say these 6 are tools of your QoS. Okay. What are these tools? First is the classification, marking, polishing, shaping, congestion avoidance, and queuing. First is classification. Whatever traffic is coming to your router, whatever the traffic is coming, first of all, classify it into different types. Okay, this traffic is voice. This traffic is video. This is data. Like this, classified into different categories. That is the first step of classification. Second is marking. Mark these packets with the priority. Okay, that okay, maybe your video traffic has higher priority, maybe your voice traffic has higher priority, maybe your data traffic has higher priority. So mark these packets or tag these packets with the priorities. Now next, polishing and shaping. These are 2 actions. These are the actions that will be taken on this particular traffic. Okay. And then we have congestion avoidance. So congestion avoidance tool, they will continuously check the devices, that which device is getting highly used. And there, according to the policy configured, they will take the action. Okay. Then we have the queuing. Queuing is what? Simply whenever the data is coming, the router will check who is having the higher priority, reshuffle the data, and arrange in a sequence so that high priority traffic will be first, then less priority, then least priority. Okay. In that order, it will arrange the traffic, and then it is going to forward the traffic. Okay. So these are the 6 tools. So one by one, we are going to see all these tools. The first one is classification. Classification is at the core of your QoS. Okay. Classification is the ability for a device to identify different type of traffics. Means you classify into different categories so you can properly prioritize one over the another. Okay, you classified, okay, this is voice, video, data, different categories, you divided it. Now what will happen? You will mark the packets. So what your marking does, marking is actually one of the optional ones. That is up to you, how you want to perform. Okay. Then marking involves tagging a packet. You will tag a packet with the priority as it enters the router. Now, let's say multiple routers are connected here. Okay. So when the packet arrived at this packet, you classified into different categories. Okay. And then you change the priority. Let's say you said this is high priority, this is low priority, and this is the least priority. Now, whenever this packet will come here, this router will not again check the type of traffic. No, it will just check the priority, that is it higher priority? First, I will forward this. Okay. So marking involves tagging a packet as it enters the router so that subsequent devices can recognize the traffic without needing to spend processor time to inspect it. They will not inspect it again. They will just check what is the priority, accordingly just forward it. Okay.
QoS is enabled in routers.
Actually, you will find it everywhere: router, switch, firewall also, even WLC also. Okay. Because this is basically for all the devices, because traffic, wherever it goes, it is going to pass through a device, and there you're going to need QoS. Okay. I'll show you. Right now, we'll do the wireless practical. There we have the QoS option. Okay. We'll not be able to set because that feature is not supported itself. Polishing and shaping, these are the two actions. So in polishing and shaping, simply what you're going to do, you are going to set a threshold limit. Okay. So you will set a threshold limit that maximum the other data can use, let's say out of 100 Mbps, it can use 40 Mbps. Okay. Now what will happen? Whenever the data traffic tries to go higher than this, there are two actions. One is polishing, one is shaping. In case of polishing, what will happen? Whenever the data tries to go at the higher end, means tries to consume more bandwidth, this extra traffic will be instantly cut off. Instant drop, no second choice. Okay. But what happens in the shaping? In case of shaping, whenever the data tries to take higher bandwidth, this extra data will be stored in the buffer. And whenever at a later point of time, there is a dip, this extra data will be accommodated here and it will be sent. So in case of polishing, the data will be instantly dropped. In case of shaping, the data will be stored in the buffer and will be forwarded at a later point of time. Okay. So polishing, this is, you can say, this approach you will take for the data that is least important. That is the least important. So that during congestion hours, see, these things QoS will take place only during the congestion hours. Okay. Now what will happen? If the least priority traffic tries to take more bandwidth, then what will happen? It will be dropped. Okay. And let's say there is some traffic that is important to your company, but not as important as your high priority traffic. So what will happen? There you can go with the shaping approach. Shaping will create some delay. Obviously, there will be some latency, but still the data will not be dropped. It will be forwarded. So quality of service polishing allows you to set an upper limit. And when traffic hits that amount, the tool cut off the traffic and doesn't allow it. The extra traffic, instant cut off. What is the shaping? Shaping is a little bit like polishing only, but it is a kinder, or you can say gentler version. Shaping is for the traffic that you care about. Polishing might kill the packets to save the bandwidth, but shaping tools hold the access data in the memory and try to transmit it at a later point of time. Okay, so they will store it in memory or buffer and they will forward it at a later point of time. Is that clear? Then we have congestion avoidance. So with the name itself suggests that these tools are going to shut down the possibility of congestion by watching for certain limits on a router and then taking the action. Whatever polishing or shaping you have configured, accordingly, they will take the action. So as a router's traffic builds up, congestion avoidance tools look for the devices that are in the highest risk of consuming the entire bandwidth amount. And if there is a device that is at the highest risk of consuming all the bandwidth, they will take the action according to polishing and shaping. Then queuing. Queuing is simply reshuffling the packets. Okay. So with queuing tools, you can instruct a router to shuffle packets around to put the most important traffic first. So your high priority traffic should be always first to be forwarded. Okay. So these are the 6 tools of your QoS that we discussed. Okay.